Thank you all for letting me talk at your meeting. Since most of you have not come across sustainable website design before, my presentation will focus on the very basics. There's a lot more that I could have talked about, but I'm just focusing on the very basics. And after the meeting is over, I'll send my slides to Dennis to put on your website. My slides have lots of links, so you'll have all the links. Okay, that's the first slide. All right, here we go. Let me start by talking about two fields which I'm interested in that until a few years ago I considered separate. Those were the environment and computers. I've been a member of two environmental organizations, the Nature Conservancy and the World Wildlife Fund, and I've become more aware of environmental issues. I'm also heavily into computers. I graduated with a college degree in what would today be called computer information systems. I've had full and part-time jobs using computers, making and managing client websites, using computers for multimedia and more. I'm also the webmaster for the Princeton Macintosh Users Group, and I'll talk about that later. So I guess it's safe to say I'm heavily involved in computers. These fields seemed unrelated to me, but that changed when I read a blog post in November 2022 about the semi-yearly United Nations Climate Conference known as the Conference of Parties, COP. This blog post I read gave a passing mention of sustainable websites. Now, I make websites. I've had not heard the term sustainable websites before. So I looked into sustainable website design and I researched it. The goal of sustainable website design is to lower the amount of carbon dioxide your website generates, and carbon dioxide is the gas most responsible for climate change. And I'll have more to say about this in this talk. The combining of my interest in computers and the environment really grabbed my attention. Because of the COVID-19 pandemic, more people were relying on the web in 2022. Instead of doing things in person, more people were doing them online, finding information, having virtual doctor visits, virtual education to varying degrees of success, shopping online, and working from home. Now, I make and update websites for a living. So producing a website that people will use now took on a new dimension and importance, both because of the pandemic and because of the goal of sustainable website design to lower carbon dioxide emissions. I'll talk about it shortly, but it takes a lot of energy to power the web's infrastructure, and electricity generation plays a key role in climate change. Now, climate change is the problem. I mentioned climate change. Climate change is caused by the burning of fossil fuels, which are oil, coal, and natural gas, otherwise known as methane, usually methane. These are called non-renewable energy sources. Burning fossil fuels generates carbon dioxide, represented by the symbol CO2. CO2 is carbon dioxide is a greenhouse gas, which in the atmosphere both traps in heat, shifts weather patterns, and increases the likelihood of extreme weather. Floods, downpours, tornadoes, heat waves, cold snaps, and drought are all caused by climate change and extreme weather. Climate change is real and is happening right now and has real world effects. While I could mention the extreme weather the US experienced this year alone and the damage and loss of life it's caused, I'll instead mention the effects closer to home. First, there's health. With climate change, you can have the risk of heat stroke, increased infections from wildlife parasites because of shifting livable areas, uh, infections from what, yeah. Smoke and soot in the air from wildfires burning in drier conditions cause breathing issues. Then there's the economy. Farm crops don't grow as well, and there are less of them. That increases food prices for consumers. It's all supply and demand. There's also insurance. Some insurance agencies are dropping coverage for homeowners and businesses in areas prone to flooding and forest fires. Climate change is happening now, but the good news is that awareness is growing and many industries are changing. The IT industry, the information technology industry, has a part to play because it takes a lot of electricity. It takes a lot of electricity to keep the internet infrastructure going. Uh, I want to put some statistics here, but a lot of them were not really recent. A lot of them were mostly around from 2019 and 2020. Here's one from 2021. The carbon footprint of our infrastructure, our gadgets, and all the systems that support the web and the internet, carbon footprint is similar to the airline industry. That was back in 2021. It's probably more right now. Here's another one. The infrastructure of the internet, data centers, data transmission networks, and end user devices emitted 1 to 1.7 gigatons of carbon dioxide in 2020, and that surpasses the greenhouse gas emissions of the countries of Australia and France, or France. A lot of electricity goes to power the infrastructure that makes the internet and the web, which is part of the internet, possible. You have data centers. These are large warehouse-like buildings which house aisles and aisles of server computers with banks of storage drives for data and files which make up websites. These require power for operation, and these servers generate a lot of heat, so it takes power for air conditioning to cool these servers. Then you have wired and wireless network transmission. Data needs to be sent and received from the centers, and there are devices which control, send, and receive data through cables and the cell network, like routers and switches and wireless gear. These require power to transmit the data to reach you and the data that you send to reach the servers. And probably the thing that you're most familiar with are the actual devices that you use to surf and use the internet. These are devices which receive and display websites. These are desktop computers, laptops, tablets, smartphones, and similar devices like Chromebooks, web TVs, ebook readers. And these require power to receive data and display it on the screen. I should also mention that it takes energy needed to plan, design, manufacture, distribute, and recycle and dispose of all these devices throughout the infrastructure, from data center servers to the routers to even your smartphones and laptops and other computers. All of these activities require electricity. Now you're probably thinking, okay, we're talking about electricity here. Electricity is green, isn't it? At the end of the day, and I need to charge up my smartphone, I just plug it into the wall. All electricity is green, right? Ah, it turns out that that isn't the case. The devil is in the details. The power outlet on the wall is only the end of the electricity chain. That electricity has to be made somewhere, and that somewhere is the power plant. Power plants generate electricity, transmit it through the electricity grid to your home, then to your wall outlet. And as we will see, some power generation methods produce more carbon dioxide than others. Now, this is an interesting website. This is electricity maps. Let me bring this up. Okay, so we can go just about anywhere in the world with this, and it shows us the carbon intensity of various regions and their electricity power generation methods. And since we're in the Northeast here, let me zoom in. Now you notice immediately at first the colors. There are different colors in different regions. And if I highlight this here at the bottom right-hand corner, you see carbon intensity. So renewable electricity resources like solar or geothermal, they would be green. And electricity generation methods that produce more carbon dioxide or the most carbon dioxide, like coal and oil, they're represented by the darker colors over here on the right. Now, you'll see that we don't have individual states. What we have here, for the most part, are regions. And there are regional companies which coordinate the electricity generation, distribution, and pricing over a multi-state area. So in this area here, if I click on it, the one which includes New Jersey and Pennsylvania, you'll see that that is controlled by a company called PJM Interconnection. And they're a regional transmission organization. Also, when you click on these regions, you'll notice here on the left-hand column, you'll see various energy generation methods. Here you have in the right-hand corner, top right, production and consumption. So if we're on production, you can see the most in our region is generated by nuclear and gas. Now, right now, we're in the evening hours, but you can shift that to during the day. And you can see that the mix changes. Like during the day, gas becomes more than nuclear. So there is a mix of energy generation resources available that provide power through the electricity grid. All right, so here we are in the Northeast area, and for the most part, it's nuclear and gas which produce our electricity. But if I go to another area, say, for example, California, let me bring this during the day here. Okay. Now, California gets, there we go. California produces most of their electricity through solar and with very minor other sources. Some gas also. I guess gas is the second most abundant energy generation source. Now, if we go to a place, say, like Washington State, don't like how when you click on this, it zooms out. Zoom back in. Washington State, that's all generated by hydroelectricity. And I'll do one more. Now it's a dark color here, so it's very carbon intensive. This is South Carolina. South Carolina generates most of their electricity through coal and gas. Let me go back to Zoom. Okay, here we go. Where is the window? Oh, I know. Okay. Okay. So key takeaways are that electricity comes from a mix of both renewable and non-renewable power generation sources. Non-renewable power generation produces more carbon dioxide. What this means for websites is the less energy used by a website results in less non-renewable energy used from the energy generation mix of renewable and non-renewable generation sources. Now sometimes you'll hear what's low uh, called a low carbon website. A low carbon website is built with components which use less electricity, hence less non-renewable energy used from the energy generation mix. You'll find that if you're in the electricity maps website, that during the day, you'll see more of a combination of renewable and non-renewables. And as the evening hours go on, although non-renewable energy generation goes down, goes down the most are renewable resources, because the renewable resources provide extra power to meet the demand of the daytime. As I mentioned before, we use the World Wide Web for many tasks: finding information, virtual doctor visits, virtual education to varying degrees, shopping online, and working from home. If we want to continue to do these things now and in the future, then we need to be more energy efficient through how web pages are put together, so they require less electricity, emit less carbon dioxide in the process, and the web can continue to be there for us in the future. Sustainable website design is a relatively new field. It's a handful of years old, and it's still finding its way. And the exciting thing is that new information is constantly coming along about new techniques that you can try and things that you can do to make your website more sustainable. These techniques apply to websites. There are new techniques which apply to websites. While the goal of the US government's Energy Star program is to save electricity, the goal of sustainable website design is to lower carbon dioxide emissions through software. Now that leads to the question, is my website sustainable? Well, there are various web-based programs which will test pages to get that answer. Here are two of them: websitecarbon.com and EcoGrader. So let's have a look at these. Let me go to website Carbon first. Now, as I mentioned, it's a website. So all you have to do is plug in the web address of the website you want to test. Let's say Amazon. Amazon.com. Click on calculate. And it goes to Amazon, looks at the resources that are served back, and it shows you its results. And it says, this website is dirtier than 73% of the web pages globally that website Carbon Calculator has tested. They have to be submitted so it can compare the website that you're submitting to all the websites that have been submitted so far. So it shows you the global average and it shows you the rating of this website here, Amazon.com. And it tells you what that really means in relatable ways. So I scroll down farther, it says it's the equivalent of boiling water for 15,000 cups of tea. How many chargers of a smartphone? Bubbles. Trees, how much carbon dioxide a tree emits in a year. This is how much Amazon emits in a year, 6 trees worth, and how far you can drive an electric car through the amount of electricity this website uses. And the other website is EcoGrader. So EcoGrader is similar to the website Carbon Calculator, but it's more detailed. So let me see if I can go to Amazon again. Tried this before, and as you can see, because Amazon got an F on the website Carbon Calculator, and I tried to run Amazon through this one, it sort of choked. Let's see how it does again. No, it choked. Actually, I tried making a new private window. Let me try that, see if that works. Ah, did load. Okay. So this also scores the website. Now, the thing to pay attention to here is that Amazon scored worse than 96% of all websites crawled by EcoGrader. So EcoGrader will go out and crawl the web and see how sustainable that website is that it crawled to. EcoGrader also breaks out into various categories how you've scored, such as the page weight in kilobytes, its user interface design, and green web hosting. This one gets an E, which I suppose is like an F. If I scroll farther down, it shows you a breakdown of all the components of the page that we've tested on Amazon.com, the main page. For different websites, the breakdown will be different. Just so happens to say like a little less than half of Amazon.com has images on it. Then you have other media, and then you have scripts, and then you have HTML, the language of the web, and CSS, the styling language of the web. And now it takes you through those 3 categories, and it shows you the score of subcategories. And if you expand it out, say like this one here for overall page weight, well, it will actually detail the files and show you the file size. So EcoGrader is used for analyzing a website's sustainability and telling you exactly what files are potential issues. Now, the website Carbon Calculator is good for a overall analysis of a website. If you want to break down the very detailed information, then I would use EcoGrader. A few notes about both of these websites, EcoGrader and website Carbon Calculator. Both score the website against other websites which have been submitted. That used to be the case also on EcoGrader, but it seems now that EcoGrader also actively goes out and scans websites. The results between these two, EcoGrader and the uh, website Carbon Calculator, usually are different, and that's because the test results are estimations. The carbon dioxide measurement methods will become more refined over time, but they are estimations. And they also use different calculation methods. So there are bound to be differences in results, the exact numbers that they report. Going back to here. Okay, if helping the environment isn't reason enough to have a sustainable website, then perhaps its side benefits are. First, there's the user experience. A sustainable website loads faster and you wait less. For search engine optimization SEO, a sustainable website loads faster, and on mobile devices, because of that, Google ranks faster loading websites higher when you do a search. In the area of accessibility, which helps people with special needs online, the website operates faster, so it's more usable. For mobile devices, the battery life is better because a sustainable website uses less data. There is less to load and process. It takes less energy to render all the page elements on the screen, so reduced data saves on mobile device battery power. Okay, all right. Now I've talked about why a sustainable website helps reduce carbon dioxide. Now let's see some methods on how to make one. In the early days of the web, websites were built using pages which contain both content and the website's layout. As time went on, and with more and more pages to add and edit, it became more cumbersome to make updates. Then came out what is known as a content management system, a CMS. A content management system separated out how a website was built and its look and feel from that of its content. One such content management system is WordPress, which is what I use to make and maintain websites with. However, a lot of the following strategies I'll talk about next apply to other content management systems. So, one strategy is to reduce data. And by reducing data, you have less to transmit, and that reduces energy. Thereby, less carbon dioxide is generated from non-renewables in the energy mix. And you can do that through having smaller image sizes. You can compress files to a level just before there's too much distortion. You can do that manually for each image, or you can use CMS plugins, which will automatically do this for you. The end results may vary. You can also do that inside of a graphics program like Photoshop and Affinity Photo, or you can do that in an online program like Short Pixel. So let me just briefly show you Short Pixel. So with Short Pixel, you can upload an image and you can set different compression methods. So let me upload an image here. And before I do, let me go to the settings and talk about this a little later. But in the settings, you can generate not only JPEGs, or PNGs if that's what you initially submitted, which are smaller, but also SurePixel can make WebP graphics and AVIF graphics. Let me collapse this here. You can control the compression level here. By default, it has the most compression, which they call lossy. In the middle, not as much compression as what they call glossy. And lossless is compressed the least, but it produces the largest file sizes. I think I'll come back to this one. No, I should stay in there. Okay. Okay, another thing you can do, you don't have a bullet point for it, is to make the image physically smaller. If you have a photo that you've taken out of your camera and you want to use on a web page, the thing not to do is take the file and just transfer it to your computer and upload that, because these files are humongous. They're like 5,000, 10,000 pixels in width across, and really don't need that high resolution to put on your website. What you want to do is you want to have the appropriate amount of resolution of image on your website. So you can compress those in your graphics program of choice, Photoshop, Affinity Photo, whatever program you like, GIMP, and you can specify that the image be resized smaller, so it's not 10,000 pixels wide. It's now say like 1,000 pixels wide. And having a smaller resolution image produces a file size that is much smaller than say like raw out of the camera. You can also compress HTML files and JavaScript through plugins. Again, I'm talking about a content management system here. So again, plugins provide features of a content management system that are not built in. And there are plugins, for example, for WordPress that will compress HTML, automatically compress HTML and JavaScript. So you're sending less data to your smartphone or laptop. Another thing you can do is use a more efficient graphics file format. Everyone's perhaps is familiar with JPEG if they dealt with website images. There's also WebP, which is championed by Microsoft and is supported most of the time these days. It's hard to find a modern web browser that does not support WebP. And the most recent graphics file format is AVIF. Most of today's modern web browsers can also support AVIF format, although there may be some difficulties here and there, especially difficulties if you're using an older web browser. And AVIF produces the smallest file size. Let me jump out of this and show you an image that I've compressed in the 3 different formats. So here I have the original file, which is 2.1 megabytes big. Let me open that. And then when I say that as JPEG, it's 174K. If I compress that in WebP format, That's 141K. And the newest format of all, AVIF, if I compress that. Oh, sometimes AVIF, it really depends on the image. Sometimes the AVIF image is a little bit bigger than WebP, so you really have to check. But most of the time, AVIF will be smaller than WebP. It just so happens in this particular image, it's 165K, a little bit larger than WebP. Now, if you're going to use WebP images or AVIF images, you'll want to make sure they can be seen in the web browser. And as I mentioned, some of the older web browsers have problems displaying, for example, say like WebP or AVIF image files. So what you want to do is you want to have fallback. You want to have the image sent to the web browser, and if it can't read that format, it can fall back to a format that it can read. So for example, the most basic default format here in this example is JPEG. And of course, that produces the largest file size. If your browser supports WebP, you can link that image in. And if your web browser supports AVIF, you can link that in. And this is the structure to use here. This is the source set element that you can specify different images to use in a certain order. Right. Now, one thing that I should note is that some web servers may need what's called their MIME type modified to, to permit WebP or AVIF files. Usually it's with AVIF files that you have to change the MIME type for your server, on your server. Another strategy is to have lighter plugins. Google Analytics, and well, in this case, it's not a plugin. It's well, this is a general category. If you want to collect analytics for your website, people who do so will immediately recognize Google Analytics, and it provides just about every feature you can imagine, sort of like the Photoshop of analytics. But it's bloated and it's big, and it can make your website load slower. An alternative would be to use cabin analytics, which is smaller, lighter weight, and loads faster. Cabin advertises itself as 22% to 22 times smaller than Google Analytics and loads twice as fast. Now, as far as actual plugins are concerned, talking about analytics before. Now I'm talking about actual search engine optimization plugins. If you use SEO plugins, you'll probably recognize Yoast. Again, they have a lot of features, but the Yoast plugin is very large. It's very bloated. An alternative is to use Slim SEO. And that program is much smaller than Yoast. Doesn't have all the features of Yoast, but it probably has just enough to make it worthwhile to use. Another strategy is to reduce processor-intensive page elements. And reduced processor activity reduces the energy, thereby the less carbon dioxide generated from non-renewable sources in the energy mix. These include slideshows and carousels. You'll It's a good idea if you want to have a sustainable website to avoid these, because showing slide after slide takes processor power, both for slideshows and carousels. And this one is probably the worst of all. Video files are humongous. If you have video files acting as decoration, that's a big no-no in sustainable website design, especially if if you have their autoplay setting enabled. They're just playing when you scroll down and you see them play. It's sort of like for decoration, and background video is also for decoration. While it may have that razzle dazzle element to it, do you really need that? It's going to slow down your website. And on older web browsers, it can use up resources so much that it makes it difficult just to scroll down the web page. Another processor intensive page element that you'll probably want to avoid if you want to have a sustainable website is endless scrolling. Think of Instagram, how on your home page feed for Instagram, you scroll down and more pictures show up. And you scroll a bit more and more pictures show up, and it never stops. And that's to encourage you to keep on scrolling until you find something that you like. In terms of a website, this may be comparable to, say, a news page showing story after story after story. The thing to do in that case is to have a few stories, say like 4 or 5, then have a link underneath that says view all stories, which when clicked on will take you to a page that shows you all the stories. So you're making the intention to go to another page and see that content rather than trying to be seduced to keep scrolling and scrolling until you find something that you like. And there are other strategies. There's a strategy called lazy loading. And what that does is it only loads the immediately visible page element on the screen at that time. So if you're viewing a website, the only elements which will load are the page portion that you're viewing right then. If you scroll down, then those lower page elements will then load in. So you're not loading in everything at once. You're loading it in only if you need it. That's lazy loading. Another strategy is caching. Besides, there are CMS plugins to cache your website in different pages. There's also caching on the server itself. So those were some strategies and methods which improve a website's sustainability. Now let's see what happened when I put them into practice. So I ran the Princeton Macintosh Users Group website through the website Carbon Calculator before it was made into a sustainable website. And it gave a score of better than 78% of web pages tested. That's like a C+. It's not bad. It's okay. It's decent. It's all right. After after I made the PMUG website sustainable and I ran it, this is the next day, the 18th and the 19th. The PMUG website was now better than 89% of the pages tested. That's like a B+. And just last month, when I ran it, gave me an A+. And it's better than 92% of the web pages tested. EcoGrader is a harder sell. It's harder to get a good score on EcoGrader. So before the sustainable redesign, you had the page scored 70 out of 100 points. After it was redesigned, it scored 74. And last month it scored 75. the amounts are very small. The newer redesign of EcoGrader now shows you its grade level here, A. So I'm the webmaster of the Princeton Macintosh Users Group website. During November 2022, our server administrator, who is also our president, was preparing to update the server language WordPress uses, which is PHP. A new version of PHP came out and it was faster and more secure than the previous one, so we wanted to update it. We duplicated the PMUG website to a test server, did the update there, and I checked things out. The website had major layout and style issues that I would need to fix. About that time, I learned about sustainable website design, and I thought that if I was going to do a lot of work on the website anyway, why not make it sustainable? So having a sustainable website was approved by PMUG's board, and I went to work on the changes. And when all was said and done, PMUG had a sustainable website, although we didn't promote it as such. So here's how we did it. These are the things that I most attribute to the improved scores. Before, on the website Carbon Calculator, as I showed, it was better than 78% of the web pages tested. And then afterwards, it was better than 89% of the web pages tested. And the EcoGrader was harder to get a good score on because of the methodology it uses. A good portion of the file size reduction came down to recompressing graphics that were part of the website's look and feel. And in most cases, I was able to adjust these images manually. This only needed to be done once, and paying attention to images that were part of the user interface on every page brought benefits to every page. I used the picture tag with source set, and I linked to both WebP and JPEG image versions. I used lazy loaded images. I used caching and minimization plugins. And my overall thoughts after all was said and done on sustainable website design was that green hosting in itself won't give you the amount of carbon dioxide reduction achieved by making the website smaller, slimmer, more efficient, and used less processing power. Because a green server wasn't an option for PMUG, it was provided by our admin. So the focus was instead on having a more efficient website. The end result was that the website produced less CO2 than other websites which solely relied on green hosting. Not all companies have the time, expertise, or commitment to make their websites rank go from, say, a C to an A, which PMUG's website ranked last month, but that shouldn't stop them from making some improvements. Every gain helps reduce carbon dioxide, and sometimes a sustainable website for less nimble companies can be one which has some improvement over the previous website. The goal isn't to be the best, but instead to have a more sustainable website than before. So in closing, electricity is generated from a mix of both renewable and non-renewable power generation sources. Less energy is required for a sustainable website, which results in less carbon dioxide from non-renewable energy from the renewable and non-renewable power generation mix. There are strategies and techniques to lower your website's carbon dioxide emissions and energy use. Think about what you use the web for. We depend on these websites and want to be able to use them in the future. With climate change already here, it's critical to lower carbon dioxide emissions, and sustainable website design has an important part to play. And I have additional resources if you're interested in learning more about sustainable website design. here are some resources I would recommend. I'll give these slides to Dennis to put on your website so you can go through all these, but I have listed books and organizations and newsletters, forums, blogs, podcasts, and have some information about web development. So thank you for having me as your speaker, and I'll try and do my best to answer your questions. You can also send me email here. So thank you.